Hey everyone, so we are going to review today for our roots, graphing, square roots, cubed roots, exponential, whatever, well not quite exponential, functions quiz. Alright, so try the do now. Maria plans to rent a boat. The boat rental costs $60 per hour. She has to take a $10 water safety, and that's a flat fee. She wants to spend no more than $280. So you're going to do 280 minus 10 is 270 divided by 60. 6 goes into 27, 4 point whatever time, so 4 hours, since you can't have a half an hour. If you want to go real hard, you could do 270 is and then 60x plus 10. X has to be less than or equal. Yeah, less than or equal to. And then solve it, but you get 4. All right. Pause and try these. These are also on the worksheet. All right, so we're simplifying a cubed root. What perfect cube goes into 54? I almost said it. 27, right? So write those down, right? Your cubes are 1, 8, 27, 64, 125, 216. The fourths are 16, 81, 256. The fifths are 30. I only know 32. I don't know what comes after that. So this is 27 times 2. The cubed root of 27 is 3, and then cubed root of 2. Done. What perfect fourth goes into 80? That's 16. 16 and 5. The fourth root of 16 is 2. The 5 goes on the inside. X to the 7th, remember that's x to the 4th times x to the 3rd. Right? The fourth root of x to the 4th is x. What times itself 4 times is x to the 4th. So there's an x on the outside, and that x cubed goes on the inside. Right? Next one. All right, 160. That's an 8 and a 20, right? Nothing goes into 20. I make that negative 8, though, right? So the cubed root of negative 8 is negative 2. So that gives us 5 times negative 2. And then the x to the 4th, we get an x on the outside. So inside we get 20xy. Multiply. And another way to remember this is a root is the fractional exponent. So this is really x to the 4 over 3, right? X to the 3 over 3. 3 over 3 is 1, and then x to the 1/3, right? All right, last one. 64, that's a negative 32 times 2. X to the 15th. Y to the 5th, y to the 3rd. We need multiples of 5 since it's a 5th root. Z to the 20th, z squared. So the 5th root of negative 32 is negative 2. Negative 2 and negative 6 is 12. X to the 15th gives us x cubed, right? This is x to the 15 over 5. 15 divided by 5 is 3. Y to the 1st. And z to the 4th. Alright, so that one and then that one. And we're left with a 2, a y cubed, and a z squared. Right? All of the exponents on the inside are less than the 5. Okay, so now pause and simplify. I did change number 6. I messed it up on the worksheet. Alright, so 32 to the 2/5. So this is the 5th root of 32 squared. Now, if you have a calculator, you can do this in the calculator, but I don't know 32 squared. I want to avoid using a calculator, right? We should be able to do this in our head. So what I do is I'm thinking of it like that. it's the fifth root of 32 and then squared. What's the fifth root of 32? That's 2. 2 times 2 to the fifth is 32. So then 2 squared is 4, right? So we shouldn't be, don't square 32, and then, like, this would be something you could do without a calculator, like on the SAT, the no calculator section. All right, number 6. So fix that one on your worksheet. I kind of changed it. 125 to the negative 1/3. What's a negative exponent mean? That means 1 over. So 1 over 125 to the 1/3, and then a 1/3 is a cubed root. The cubed root of 125 is 5. 7's a little harder. So think about how can you rewrite 8? 8 is a number to what power? 8 is 2 to the 3rd. So this is the 9th root of 2 to the 3rd, right? But like before I said, we can write that as a fractional exponent. What's that as a fractional exponent? The 9 is the denominator. 3 is the power. 3 over 9 is the 3rd. So the simplified version of that is just the cubed root of 2. All right, next one. We are multiplying. So no pluses anywhere, so we're just multiplying our outsides, multiply our insides. This is 6, 2 times 3. And then the cubed root, 12 times 18 is 216. Can we simplify the cubed root of 216? Yeah, the cubed root of 216 is just 6. So this is just 36. All right, next one. Again, you should be doing these on your own. Don't just copy what I'm doing. All right, no outside numbers. They're both fourth roots. 3 times 27 is 81. X to the 10th. Now the fourth root of 81 is a nice number. It's just 3. And then this is x to the 8th times x squared, right? So 8 over 4 is 2, so we get an x squared on the outside. And then the fourth root of x squared can actually be simplified. Just like before, that's x to the 2 over 4, that's a half. So this problem should be that as your final answer, right? The fourth root of x squared is really a 1/2, or a square root of a square root. Right? Square root of x squared is square root of x. All right, so now we are distributing. So pause the video and do these. So the top one, it's just multiplying. So the cubed root of 30. And then 2 times the cubed root of 18. And then can you simplify? You can't. Right? Remember 8 and 27. 8 and 27 don't go into 18 or 30, so you're good there. Number 11, again, FOIL. 40 minus 24 times the fourth root of 8, and then plus 10, the fourth root of 10, minus 6 to the fourth root of 80. And then look, can you simplify any of these? So you can't simplify this one because 8 is 2 to the 3rd, right? That's 3 over 4. You can't simplify that. 10 you can't do anything with. However, the 80 and the 80 is 16 times 5, right? The fourth root of 16 is 2, so we get 40 minus 24, the fourth root of 8, plus 10, the fourth root of 10, minus 12, the fourth root of 5. And you can't combine any of those. The radicand has to be the same. The inside is 8, 10, and 5. Those don't go together. Okay. This one, number 12, change that on your paper. I made it a little too easy. So the first thing I do when I see a fraction like this, I usually rewrite it. So it's the fourth root of 2 over the fourth root of 5. Right? So we want to rationalize. We don't want a root in the bottom. So the question is, what do we multiply by to get rid of it? Now, when it's a regular square root, you just multiply it by itself. The problem is, if you multiply by itself, it's not going to cancel. The fourth root of 25 doesn't cancel out, right? So, look on your paper, what fourth root is a multiple of 5? 25, or 625, sorry. So we want this to be the fourth root of 625 because that will cancel out, right? So what are we going to multiply by to get to 625? 125, right? So 125. And another way to think about this is 5 to the first. We need a total of 4 of them. We need 3 more. 5 to the third, so 1 plus 3 is 4. So then that gives us the fourth root of 250. And then so we end up with the fourth root of 250 over 5. And I don't think nothing goes into 250. Yeah, because that's 5 3 times and a 2. So that's it. All right, next one. We have the cubed root of 25 over the cubed root of 3x cubed, right? So I just simplified the x and the x to the fourth. That does give you -3, but I just put it on the bottom. So what are we going to multiply by to get rid of the root on the bottom? So cubed root, cubed root. Now, since this is a 3, that's nice. That x is going to come outside. So we just have to worry about the 3. So what do we multiply by? So I have 1 3, I need 2 more. So that's a 9, right? So the top gives us 9/4 is 225 over, and we end up with just 3x, right? That's the cubed root of 27x to the third. Cubed root of 27 is 3. Cubed root of x cubed is x. All right, so that's our final answer. Okay, so now we're going to graph. All right, so look back at your graphing so you can figure these out. All right, so 14. These 14 and 15 are your square roots, right? So that's our over, up, oh no, 1 1, 4 2, 9 3, right? The square root of 4 is 2, the square root of 9 is 3, the square root of 1 is 1. What's our starting point for 14, or our vertex? That's an 8, right? Over 8. What will make the inside 0 a positive 8? When we plug that in, our square root goes away and we're left with 2. So 4 2. So that's our starting point. And then we do our shifting over 1 up 1, over 4 up 2, over 9 up 3. So it looks just like a square root symbol. Maybe a little steeper, I don't know. Depends on the problem. So 15, what is our starting point for that one? What will make the inside 0? 7, not -7, because 7 minus 7 is 0. Right? That means this whole thing goes away when we plug in 7 and we're left with 3. So our starting point is 7 3. So 7 3. So we're here. Now, what does that negative on the inside do? What does this negative do to the graph? Instead of going right, we go left. Because if you try to plug in a number to the right of 7, right? If I plug in 8, can you plug in 8? No, that would give you a square root of a negative. We can't do that. So that's why we go left. And then what does this negative do? It makes us go down. Right? And then lastly, what's this 2 do? That multiplies our up. So instead of going over 1, up 1, it's over 1, up 2. But in this case, because it's a down, so we're going to go over 1, down 2, back to my starting point, over 4, down 4, over 9, down 6. So the graph looks like this. So it's upside down and going to the left, and it's slightly steeper than the other one because of that 2 that we have to multiply by. All right, cubed roots. How do we do a cubed root? Same idea for the vertex, -1 6. Right, change the sign of the inside. So we're here. Now, this is a cubed root. What's the shifting rule for a cubed root? So over, up, 1 1. What's the next cubed root? 8. 8, and the cubed root of 8 is 2. So we're going to go over 1, up 1. But you can also take the cubed root of a negative, right? The cubed root of -1 is -1. So then we go down and left over 8 up 2, over 8 down 2. So this one, remember this one looks like this. All right, it's got that inflection point. All right, last one. All right, starting point is 5, 4. Change this, well, we're not really changing the sign. What will make the inside 0? 5, up 4. All right. Now, the outside number flips it. The inside number makes it go left. But notice with these, because they look like this, they already go left. You were able to take a negative. You can take the cubed root of a negative. So these two actually just end up switching the sign. They cancel each other out. So we're still going to go up and right because those two negatives end up canceling each other out, but we do have to multiply by 2. So over 1 up 2, and then over 8 down 4. All right, so it's going to be a little steeper. It's more like that. Okay, and that's it. All right, last one. Pause and try these on your own. I'm going to do 18 and 20 first, and then I'll do 19 because 19 is a little harder. All right, so I'm going to subtract. We have to isolate our square root. So -2 times the square root of x plus 4 equals -22. Divide by -2. The square root of x plus 4 equals 11. Square both sides. X plus 4 is 121. Subtract the 4. So we isolate, do the inverse, and solve. Right? I isolated my square root. The opposite of a square root is a square. And then I subtract my 4. So for 20, isolate the parentheses. Right? So we're going to add 8. Divide by 3. Now that I isolated my parentheses, I can do my inverse. The inverse of a to the 4th is a 4th root. So 5x minus 2 equals, what's the 4th root of 10? We don't know, so we're going to leave it the 4th root of 10. And because it's even, remember, just like with a square root, remember quadratic formula, we actually have to put a plus or minus in front. So then I'm going to move my 2 to plus or minus the 4th root of 10, and then divide by 5. So this is my answer. All right, last one, 19. All right, this is the hard one. The lesson is out there. You can go rewatch it if you want. So we need to isolate one of our square roots. It doesn't matter which one, whichever one you think is it easier for you to deal with. I isolated this guy first. So I subtracted the square root. So I got square root of x minus 5 equals 5 minus root x. And then we square both sides to get rid of the square root. But when you square both sides, this cancels, which is nice. But this is 5 minus root x times 5 minus root x. Make sure you FOIL that out. So we get 25 minus 5 root x minus 5 root x plus x. The square root of x times square root of x is x. Now I'm going to simplify it and combine like terms. If I subtract x on both sides, those x's go away. And then I'm going to subtract 25 on both sides. So I get, I did something wrong. Oh, no, that's right. Negative 30 equals negative 5 root x, and negative 5 root x is negative 10 root x. Now, if these didn't divide nicely, I would actually leave that 10 there, but it does divide nicely. I didn't have to write quite as small as I thought I did, right? So this one's actually a kind of easy one, because everything just kind of goes away. And then we square both sides, x equals 9, right? And then make sure you check. is the square root of 9 plus the square root of 9 minus 5 actually equal to 5? It is. Right? That's 3 plus the square root of 4 is 2. A lot of times you do have answers that are called extraneous. They don't actually work. All right? Look over your old stuff. Review for the quiz. See you later.